All right, Algebra 2, we're going to look at 5.4 homework for day 1 and work through these solutions. So feel free to fast forward and find the ones that you need help on. For each one of these, we're going to factor completely and then also identify the type of factoring that we're using. So for A, there's 4 terms that we're trying to factor here, and there's 4 terms there. This is typically going to be factored by grouping. So what we're going to try to do is group this into 2 binomials, and then what we do is we take the greatest common factor out of each one of these groups. So we treat them separately. So the first thing we're going to do is look at this group right here. Well, the greatest common factor, or what we can pull out of that, is going to be x squared. So I'm going to take x squared out of this first parentheses, and then what would be left over is an x minus 3. And then we look at the second grouping, which I put in green here, and look at that GCF. What can we pull out of that binomial, that mini group? And that's going to be a 6. So I pull a 6 out, and so this is going to become a x minus 3. This is exactly what you want to see with factor by grouping. Is you need to have, between these 2 terms that we're adding now, this one and this one, we're going to need a common factor between those 2 larger groups, and we do. So we have an x minus 3 here. So essentially, we take that common group, the x minus 3, and that's going to be one of our terms, and we're going to take the other parts of that, which in this case is going to be x squared plus 6, and that's going to be our second group. So x squared plus 6. Right there, and this is going to be our answer here. So if we were to multiply this out and check it, we would see that we would get right back to those 4 terms. So the strategy here is make this simple. I'm just going to say grouping. There's the type of factoring that I use there, factor by grouping. For B, we have 16x squared minus 49. So we're not going to use factor by grouping here because we only have 2 terms. There's 2 ways to do this one. If you notice the pattern on this one, this is going to be the difference of 2 squares. So if you have 2 terms here, 1 and 2, and we're subtracting, and each group here is a perfect square, then you can utilize that shortcut. So this is what it would look like. We'd have 4x squared, right? Because 4x times 4x is 16x squared. We'd also have a 7 squared because 49 is a perfect square. So you can see here that clearly we have the difference of 2 squares, and the shortcut to factoring the difference of 2 squares is simply going to be 4x minus 7 and then 4x plus 7. There's my answer. And my strategy there is the difference of squares. An alternative method here, you could use Snowflake. You can always use Snowflake on a lot of these problems. So I'm not going to do this one, but you could use Snowflake, just a typical factoring, and just know that your middle term here is 0x. So you could do it like that, and that would be totally fine. And you'd get the exact same answer, and that would be a correct answer as well. All right, part C, we have 3 terms here. Again, we have 2 different options here. We could use like a classic Snowflake, and this is going to be a this just looks like Snowflake, actually. So we have x to the 4th minus 7x squared plus 10. First of all, there's no greatest common factor that I can pull out there at all. It's not a difference of 2 squares. There's not 4 terms where I can use like factor by grouping. It doesn't look like one of those perfect square trinomials. So I would just use a Snowflake method here to start. So if we do Snowflake here, it'd be something like the A value here is 1 and 1. The C value is 10, or A times C is 10. And the middle term is negative 7. So thinking about what multiplies up to 10 and adds up to negative 7. So we're going to have 5 and 2 would be my two terms there. Both have to be negative, right? So I'm going to have negative 5 times negative 2 is 10, and negative 5 plus negative 2 is negative 7. Those are my terms. You can't reduce these columns, so that's going to be my factoring. Notice here, though, that my first term here is x to the fourth. So this will still work out with Snowflake. It's just not going to be x. It's going to be x squared. So it's going to be 1, not 1x. It's going to be 1x squared minus 5 times this column, 1x squared minus 2 would be my answer here. So I'm just going to say here Snowflake method is good. All right, D, we have 8x cubed plus 27. And so this one is going to be the sum of cubes. So this, I would say, the sum and difference of cubes are those special cases where we have two perfect cubes here, meaning 8x cubed is a perfect cube. In other words, what times what times what is 8x cubed? And we can write that as 2x cubed, right? 2x cubed is 8x cubed, and then we'd also have plus, and 27 is a perfect cube as well, and that is 3. So 3 cubed. So we have in this case, the sum of cubes is going to be our pattern or factoring that we use, and then we have to remember the pattern of the sum of cubes. So I'm just going to pull up the factoring pattern here, which is right here. So if we have two cubes, like in this case, we have a cubed plus b cubed, then the factoring pattern is going to be this on the right-hand side. We can expand it like so. So in this case, the way that we wrote this, my 2x is going to be my a, my 3 is going to be my b. So if we follow our pattern for factoring, then my answer would become a plus b, so that's going to be 2x plus 3 times a squared, which is now going to be 2x squared, right? So I'm going to go ahead and put that as 4x squared. Okay, so 2x, all parentheses, squared would become 4x squared, minus a times b. Well, let's look at that. A is 2x and b is 3, so this becomes a 6x. And then plus b squared. B squared, in this case, will be 9. So that's our start here. Then my next question would be, well, could I factor this any further? That would be what I'm trying to figure out here. Can I factor 4x squared minus 6x plus 9? And if I wanted to double check that, I would go with a traditional Snowflake method. Even though this actually looks like a perfect square trinomial that our lesson kind of taught, but I'm going to choose to just use a classic Snowflake to get that second part done. So now I look at this part right here, right, and I realize, all right, so I'm going to use Snowflake for this. So my a term is 4, so I'll go 4 and 4. 8 times c is 36, and then negative 6 goes below. So we're thinking about what multiplies up to 36 and adds up to negative 6. And so that is going to be, I don't think that works. This doesn't factor. There's nothing that works there. So I was wrong. You can't factor that anymore. This is as far as you can go. And so here's my answer. And the factoring that I use here is going to be the sum of cubes. All right, get rid of this. Let's look at E. E is 2x squared plus 11x plus 15. This one clearly looks like a Snowflake method. So we're going to go with the classic traditional factoring here, which is just going to be Snowflake. So we're going to take the A value. A times C is 30. Middle term is 11. We're going to think about what multiplies up to 30 and adds up to 11, and that's going to be 5 and 6. 5 times 6 is 30. 5 plus 6 is 11. So here's one column that's already reduced. This column right here can be reduced to 1/3. So there's the new column. And therefore, this would become 2x plus 5. And this would be 1x plus 3. And there's my factoring. And I'm just going to put this as the snowflake. I'll just put snowflake there. All right, last one, or not the last one, but F, at least for this video, we have 9x squared plus 12x plus 4. Again, this one looks like 3 and 2. This one looks like you can definitely use snowflake. So we're going to go ahead and use snowflake here. And so the A value is 9 and 9. A times C is 36. The B term is 12. We think about what multiplies up to 36 and adds up to 12. That's going to be 6 and 6. So I'm noticing now that this is a perfect square trinomial, because notice that my two columns here are the same. But remember, first I want to reduce these columns. So 9 over 6 becomes 3 over 2. So there's 1. And then this also becomes 3 over 2. So this one's going to be 3x plus 2 and another 3x plus 2, which means that this was a perfect square, because I can write this factoring as 3x2 squared, and there's my factoring. Now the method that I used here was snowflake, but you could have used, as an alternative way, you could have used the pattern of a perfect square trinomial. Again, what that would show is that we have 3x squared, and then this last term here as well is also a perfect square, so that's plus 2 squared. And the middle is 2 times 3x times 2. 3x times 2. It's kind of hard to see there, but it does equal 12x there. So I'll be honest, when I'm looking at this type of problem, I usually don't pick up on the fact that it is a perfect square trinomial instantly. I usually just go back to just normal factoring, snowflake method, the 2 parentheses method, and just do it that way. But you can certainly go ahead and use the perfect square trinomial pattern here, and that would be also good.